Hi folks, Joseph Kursky here with you to explore the new Mars 3D mapping tools based on GIS, all made possible by the USGS and ESRI. You can do things like this, measure the distance across features like Olympus Mons, which is a huge volcano on Mars. Mars is a small planet, but it has some big, impressive features. So looking at, gosh, look at this, 65,000 feet high, almost 3 times higher than Mount Everest. You can even tilt the viewer, all based on the JavaScript API, ArcGIS API, and you can see the cliff. Oh my goodness gracious, it's thousands and thousands of feet or meters high. Being able to do this and compare it to similar cliffs on the Earth, I think helps in many ways, teaching about scale, teaching astronomy, teaching science, teaching geography, teaching about GIS and how to use interactive mapping tools. And even at the top of the Olympus Mons volcano, you've got this more recent set of calderas from more recent eruptions. So even those at the top of the volcano are impressive in size. I just love this. Being able to compare is another wonderful feature. How do I get to this viewer? Do a search on Mars S3 3D Mars viewer and you'll see it. But let's say we put Texas on Olympus Mons. Gosh, how big is Texas? Well, it turns out that volcano is about 2/3 of the state, goes all the way from Lubbock to the hill country. So imagine Lubbock all the way, or Amarillo down to San Antonio just about, and you've got the size of the Olympus Mons. So it's oftentimes hard for students of any age to visualize how big features are on other planets, Ganymede, the moon, Mars, etc. But being able to do this kind of scale comparison, I think is really, again, very helpful to teach about the topics we've talked about in the past, but also mathematics. And indeed, a colleague and I wrote a book called Spatial Mathematics, where we explore the intersections in more detail. What about countries? What if we put Algeria on top of Olympus Mons or the Valles Marineris or any other physical feature on Mars? Well, again, the size of the planet isn't all that impressive, but the size of these features. What about, gosh, Switzerland on top of, what if we could rotate it, we can actually move it if we put it in the wrong spot or in a different spot. So Olympus Mons is larger than Switzerland. Pretty impressive. But teaching about scale, proportions, measurement in different units, and so on. Let's scroll on down to just to the west of the Valles Marineris, which are impressive canyons, are these fascinating fractured canyons and plateaus. What if we put the Grand Canyon on any one of these impressively sized canyons? You can see here that the Grand Canyon is dwarfed by these features on Mars. Oh my goodness. This is, again, a fascinating tool made possible through geospatial technology. So a shape of Mars had to be devised, the geodesy, the mapping tools had to be overlaid on top of that, map projections matter, and so on. Here's the Valles Marineris that I was referring to earlier. If we put a 3D model like the Grand Canyon or the Empire State Building, etc., on top of that, we can get a comparison. And you can see that, once again, the Valles Marineris is quite impressive compared to even to an impressive feature like the Grand Canyon. Oh my goodness, look at that. It fits right in the bottom of that. It's not even a third of the way up the canyon walls, the Grand Canyon that is. So let's measure this now using some of the tools we looked at earlier. We can measure again across the valley, 90 kilometers across the valley, 60 or so miles, and look at the vertical units as well with these tools at your fingertips, just in a web browser, nothing to install. You've got this at your fingertips. All you need is a halfway decent internet connection and a web browser. You can do all these sorts of things. Figure out where the Perseverance rover landed and why it landed in the Jezero crater because it was so flat, etc. It didn't have to scale those crater walls. But being able to do this sort of thing with locations, measurement, features. You can post tweets on different locations of Mars. You've got a vertical and a horizontal component. So again, angles, mathematics, astronomy, geography, science. Fascinating to have this at your fingertips. Let's measure elevation here. Notice how this tool just sort of wonderfully, magically drapes to the bottom, and you can see the vertical and the horizontal. Really quite impressive, the sheer size of this. Oh my goodness gracious. "3D models. Manhattan on the Valles Marineris." Oh boy, I love this too, because if I was then going to zoom in on lower Manhattan, and if I was suddenly on Mars looking from maybe Queens to Manhattan, look at the size of those cliffs in the distance. Truly impressive, truly impressive. I'm going to change the base map so I get a shade of relief behind me, and that's even more impressive than what we were looking at earlier, right folks? I encourage you to do this, and more importantly, get your students to do this and pose some scientific inquiry-based questions that they can ponder, that they can grapple with, that they can say, I don't know, if this doesn't make people, students of all ages, faculty, and others say, this is incredible, I don't know what will. This is, to me, one of the most fascinating applications of geospatial technology. 3D models choice once again. Ooh, Mount Kilimanjaro inside the Valles Marineris. Mount Kilimanjaro is pretty impressive on the Earth, and it's still rather impressive on Mars, but if we put that on the bottom of that canyon, we can see that those cliffs are still higher than Mount Kilimanjaro. Amazing. I mean, don't get me wrong, I'd still rather live on the Earth. We do have a lot of advantages: air, nice temperature, nice people, water, other essentials of life. But it is fascinating to look at this. Okay, folks, thanks for exploring that tool with me. I encourage you again to do this at multiple levels: primary, secondary, community, technical, tribal college, university, libraries, museums, after-school clubs, lots of places where this could work, and even with friends and family members, to show them this is what GIS is, this is why it matters to our world, and also, hey, to other worlds. Thanks. Scale matters as well, so change the scale, change the rotation. Ask yourself, how do latitude and longitude lines get measured on Mars? Mars doesn't have an eastern and a western hemisphere. It actually goes from 0 degrees longitude all the way 360 degrees around to the prime meridian, which is exactly the same location. Latitude-wise, it's the same as Earth, 0 to 90, north and south, the north and south poles, but it's 0 to 360 for longitude. Fascinating. And how was the line of the prime meridian determined on Mars? Do some investigation on that as well. Here is, you saw the Perseverance location. I've got another video that explores the Perseverance rover on Mars using these 3D tools. And we're back on Olympus Mons now, but looking at a different base map. Let's put Everest on Olympus Mons now, using the same technique that we were looking at earlier for the Valles Marineris. And you can see here that Everest is, of course, as you would expect, dwarfed by the Olympus Mons. Fits nicely on a piece of it. If we put the whole Himalaya, though, range on there, it would occupy a fair amount of the surface of the Olympus Mons, but of course it would not be as tall as Olympus Mons. Let's say we want that Mount Everest to be at the base of Olympus Mons. We can do that as well. We can rotate these shapes that we put on there, and so on. And if you want to dig deeper, the ArcGIS API is available to you. So if you've got some students or fellow colleagues that love to dig into code, you can create your own applications with those tools, those SDKs and the API at your fingertips. And with the configurable apps like Web App Builder, Experience Builder, and Story Maps, you can make your own out-of-the-box, without any coding, web mapping applications as well. So this is the Mars Explorer 3D web mapping application. I encourage you to investigate this in multiple disciplines at multiple educational levels. Thanks.